Hello, this is Elizabeth from the Academic Support Center at Raritan Valley Community College. Put together a video to just help you out with section 13.1, which is circles and parabolas, but we're just focusing on circles. So we start with the definition of circles. And the definition of circles, as it is in your book, is that a circle is a set of points that are the same distance from a fixed point. So this same distance from a fixed point. This fixed point is our center. Center. And the same distance is our radius. Oops, I want to keep this in blue. So this same distance is our radius. Now in the general form for the equation, our radius is r, and our center is a point, and we're just going to call this point HK. That's our center. Now, the general format for the equation of a circle is just, we have x minus the x component of our center, which is h. I'm going to square this, plus we have y minus the y components of our center, which is k. All of this is squared, and this is going to equal our radius squared. Okay, so this is the general format for a circle. If you're like me, a lot of you are happy with the equations. I like to know where my equations are coming from. So I'm just gonna take a minute and go through where this is coming from. If you understand where it's coming from, sometimes it makes a little bit more sense and it makes it easier to remember, or at least for me. I know there's all sorts of different learning styles, so if this doesn't work for you, then that's fine. But we have our center point here. This is our HK, okay? That's our center point. Just by definition, we're calling our center point HK. We have a given radius. This is a radius of our circle. This is our R. Okay, I'm going to try and draw a circle. It's probably going to be far less than perfect, but essentially if we take this radius and we drag it along the outside, we'll get a circle about that center point. And in theory, if I've drawn it well, which I haven't, but any point on this circle is the same distance from the center. So this is our R. Okay. Now, if we take a look at this, I'm going to just blow this up a little bit so that we can see this better. But if we look at this, we can draw a right triangle. Let's see. We're going to draw a right triangle. We can draw just out along parallel to the x-axis and this side here. Oh, that did not do what I wanted it to do. Okay. So this side here, so now we have this point, any point on our circle, we can call it x, y.
I can learn to...
Okay, so this is our x, y, and we can say this green side, this is our HK, this green side here is our change in x from our center to our point. So this is our delta x. It's our change in h from our center point to our point on our circle, and this is our change in y. Okay, so when we work with these equations, the difference between the change in x and the change in y, well, how do we calculate the change in x? The change in x is going to be x1 minus x2. So we're just going to say any point on our circle is x minus our center point. Well, the x of our center point is our h. So that's our delta x. Our delta y, likewise, is equal to, delta y. y minus our y component of our center point is k. Now, if you recall, if we have the general Pythagorean theorem, we have we have a triangle. We have a right triangle, a squared plus b squared is equal to c squared. Okay, so now by design we've drawn this right triangle like this. So the green side is our delta x. So that's our a. So that's going to be our delta x squared. We're going to add our b squared, which is our delta y squared. And this is going to be equal to our hypotenuse squared. Well, our hypotenuse is r. So this is r squared. Now, if we substitute what we just did here, we get x minus h is our delta x squared, plus our delta y is y minus k. Again, this is squared. And this is equal to our radius squared. Radius squared, which you can see is this equation that we had this equation that we had up here. Sorry about that. This equation that we had up here. Okay. So one other important thing before we start looking at examples and theories is what if our center is equal to 0, 0. This equation becomes 8x minus 0 squared plus y minus 0 squared is equal to r squared. So now we can simplify this. X minus 0 is just x. So this becomes x squared plus y squared is equal to r squared. So if we had an example that looked like that was x squared plus y squared equals 9. Well, now this is just a circle. Our center is equal to 0, 0, because we just have x and y. We're not shifting that any by adding or subtracting it before we square it. And our radius is equal to the square root of 9, which we know is equal to 3. Okay. So I wanted to look at just one quick example here. Let me click out of here. We're going to go over here. We're going to look. I want to copy this just over here. So let me see if I can get this. Oops. I can get this. Oops. Try one more time. Yes. I want to copy that. Bring this over. Oops. Sorry about the technical difficulties here. Let me try one more time. If not, we'll just take this and go over here. Let's see. Yes. Okay, good. Oops. So I want it a little bit up here. Sorry, bear with me. Just 1 minute. Okay. So this is a general form of our equation. I'm just going to get out of here, blow this up a little bit over here. So if we have, this is our general form of the equation. If we have something that looks like x plus 1 squared plus y minus 3 squared is equal to 4. Okay, so this is our equation, and we want to graph this equation. So the first thing that we want to do is we want to find our center, and we want to find out what our radius is. So let's rewrite this so it looks a little bit more like this. This plus 1 is x minus a negative 1 squared plus y minus 3 squared. We can write this 4 as 2 squared. So now this is in the format of our standard equation. So we can say that our center is at -1, 3. And that our radius, that's our 2 squared, is our radius squared. So our radius is equal to 2. So now we can go ahead and graph that. And I'm just going to come over here and make this a little bit bigger. So our center is at 1, 3. So I'm going to plot that, -1. So -1 and up 3. This is our center. Okay. Now, our radius is 2. So what I usually do is I start at my center and I go 2 in each direction, positive and negative. So I'm going to do 2 in the positive x direction. 1, 2. I'm going to put a point here. That's going to be part of our circle. We're going to start here. We're going to go down 2. So that means that we're down 2 here. We're going to go to the left 2. 1, 2. This is a point on our circle. And we're going to go up 2. 1, 2. So now we have this circle. Now, I'm not perfect. I'm going to try and draw a circle. It's not going to be good. But we're going to try and connect these dots and make a circle, something like that. Okay. So now we've plotted this equation. This is our x plus 1 squared, y minus 3 squared is equal to 4. So again, our center is -1, 3, and with a radius of 2. Okay. I am going to I wanted to keep this a little bit, I think this is enough in one lesson. I have a couple other videos that I'll record that have examples that are similar to the homework problems that you've assigned. So please look at, this will be 13.1a. There will be a B and a C, so please take a look at those as well. Okay. Academic Support Center is here to help in any way possible. During the COVID-19 virus, there is links on web pages for emails to request a meeting, but we're here to help you. We want to help you. If you have any questions, please feel free to reach out for additional help. Thank you.